Hi guys, trust you're doing fantastic. In today's video, I'll be talking about the concept of series and parallel networks. Now let me bring to your mind that there are two ways in which components may be connected together in an electric circuit. One way is in series, which is components are connected end to end, and the other way is in parallel, where components are connected across each other. When a circuit is more complicated than 2 or 3 elements, it's very likely to be a network of individual series and parallel circuits. Now let's begin with this diagram, which shows resistors connected end to end, that is in series. Now with a battery source of V volt, since the circuit is closed, a current I is going to flow and the potential difference across each resistor may be determined from the voltmeter readings. We have V1, V2, V3. Now bear in mind, in series connection, there are two things you need to understand. The first one, you need to understand that the current I, it's going to be same all through the circuit. And two, you need to bear in mind that the voltage V is going to vary. Okay? It's going to vary across the resistors. That is the two things you need to bear in mind. In series circuits, like I said, the first thing you need to know is that current I is going to be the same in all parts of the circuit, and hence the same reading is going to be found on each of the two ammeter, which is this ammeter 1, this is ammeter 1, and then we have ammeter 2. All right. Then the second point you need to note is that the sum of the voltages, which is V1, V2, and V3, is equal to the total applied voltage. So what that means is that the voltage will vary across each resistor as current is being flowed through the resistor. Now in this case, the resultant voltage will be equal to the voltage drop across each resistor. So we're going to have the formula V equal to V1 plus V2 plus V3. That is the voltage drop across each of the resistor. We have resistor 1, resistor 2, resistor 3. So this is the principle you need to understand. Now in that case, it will have to consider what Ohm's law says. Now Ohm's law says that your V equal to IR. Remember our previous video, we used a simple method which is more like a triangular method, okay, which we have a bar across and then we have this bar. So what we did is that we said V is up here, we have I, and we have R. So the horizontal bar indicates division, and then the vertical bar indicates multiplication. So at each point you have I equal to V over R. And then we have R equal to V over I. And then we have V equal to IR. Okay, so using this triangular method keeps you in check. Now coming back to the voltage drop across each resistor, it means we're going to have, since we have V equal to V1 plus V2 plus V3. So for each component of this voltage, because the summation of this voltage fragment or component, it's going to give us the resultant voltage, which is V. So in that case, we will have to represent them using Ohm's law. So what we're going to have something like this. We're going to have I, since I is going to be constant all through the circuit, So I is going to remain I. So we're going to have I multiplied by R1 plus I multiplied by R2 plus I multiplied by R3. So this is what we're going to get. Now, if you're wondering, why is it that the I do not vary? Why don't we have I1, I2, I3, just like we have R1, R2, R3? Now, this is the principle. For series connection, the I is going to remain the same. The I is going to remain constant all through the circuit because the resistors are connected in series. So the I is going to be the same. Now let's consider this exercise. It says for the circuit shown below, determine A, the battery voltage V, B, the total resistance of the circuit, and C, the values of resistance of resistor R1, R2, and R3, given that the PDs across R1, R2, and R3 are 5V, 2V, and 6V. So in this case, since we have all of this, the first thing you're going to do when solving questions like this in either physics or electronics or in circuits, the first thing you need to do, you need to list out the parameters that has been given and then identify the parameters that has not been given and that are required for you to provide the values for those parameters. All right, so the first thing we're going to do is to identify these parameters. V1 equal to 5 volts, V2 equal to 2 volts. We have V3 equal to 6 volts. We have I has been given to us as equal to 4 amps. So for a series connection, remember the I is going to be constant, while the voltage is going to vary across the resistors. All right, so the first thing we have to do at this point is to remember this formula that says V equal to V1 plus V2 plus V3. So once you have this at the back of your mind and you also know that R equal to R1 plus R2 plus R3. So this makes your work very easy. So in this case, all we need to do is to use the formula, which is V equal to IR. Since we know the total voltage, we can calculate the total voltage because each of these voltage components, the voltage drop, each of the voltage drop has been given to us. So we need to get the total voltage. The total voltage V is going to be V1 is 5 plus V2 is 2 plus V3 is 6. So that will leave us, so V is going to be 13 volts. So this is V. V is going to be 13 volts. So in that case, we can say which is the total resistance is equal to V divided by I. Right? So that will be equal to V is 13 divided by 4, which is I. And that will give us 13 divided by 4. That will give us 3.25 amps. So it means we've been able to get the total resistance R. Okay? Since we've gotten this, so the next thing we need to do is to determine R1. Because A says we have determined A, which is the volt. This is A, which is the volt of the battery, which is 13 amps. Then we have also determined the total resistance of the circuit. The total resistance of the circuit is this, which is B. So total resistance of the circuit is 3.25. We have done that. The next thing we need to do is to calculate R1. For we to calculate R1, we need to say R1 equal to V1 over I. Now don't forget, the I is going to be constant all through. So what is V1? V1 has been presented to us as 5. We're going to say 5, and then the current is 4. So this is going to be 5 divided by 4, which is 1.25 ohms. R2 is equal to V2 divided by I. And V2 has been given to us as 2. So 2 divided by 4, which is equal to 0.5 ohms. 0.5 ohms. Okay. So that is 0.5 ohms. So R3 equal to V3 divided by I. So V3 has been given to us as 6 divided by 4, which is a current. Then this is going to give us 1.5 ohms. Now we have gotten each of these resistance for R1, R2, and R3. Now for we to have the total resistance, which is, let's call it RT, equal to R1 plus R2 plus R3, which is equal to 1.25 plus 0.5 plus 1.5, and that will give 3.25 ohms. And this is equivalent to what we calculated before. Now let's go over to the next exercise. The next exercise says, for the circuit shown below, determine the PD across resistor 3. If the total resistance of the circuit is 100 ohms, determine the current flowing through resistor R1. Find also the value of resistor R2. Okay, so the first thing we need to do in this case, we need to identify the parameters that have been given to us. Now we need to understand that V, total V, that's the resultant V is 25 volts. That's the battery voltage source is 25 volts. And then we have V1 to be equal to 10 volts. We have V2 to be equal to 4 volts. We have V3 to be unknown. All right, so the total resistance has been given to us, which is RT is equal to 100 ohms. So we've taken note of this. Now we don't have I. I is unknown. Now remember from Ohm's law, it says V equal to IR. Since we have the total voltage as 25 volts, we have the total resistance as 100 ohms. From there, we can get the current. So that makes it easy because the current is going to be the same all through. In that case, all we need to do is to get I. So I equal to V over R, which is equal to 25 divided by 100. and that will give us 0.25 amp. That will give us 0.25 amp. The next thing we need to calculate is to calculate V3. Now we know from the formula that V equal to V1 plus V2 plus V3. We know what our V is 25 equal to V1 is given to us as 10 plus V2 is given to us as 4 plus V3, which is unknown. So in that case, it will make V3 the subject of formula. We're going to have V3 equal to 25 minus 10 minus 4. So if you do this, we're going to have 25 minus 14. And that will leave us with 11. So V3 will be equal to 11 volts. So since we've gotten V3 as 11 volts, now what will be the value, the resistance of R1? For we to get the resistance of R1, it's going to be R1 equal to V1 over I. Remember, I is constant all through the circuit for series connection. So once we have this, we know that V1 is equal to 10. And we have calculated our current to be 0.25. So it's going to be 10 divided by 0.25 divided by 25. And that will leave us with, so that will leave us with 40. That will leave us with 40 ohms. Then R2 will be V2 divided by I. Now we know V2 to be equal to 4. So we'll have 4 divided by 0.25. And that will give us 400 divided by 25. Then that will give us a total of 16. So this is the solution for R2. Let's consider the third exercise. A 12-volt battery is connected in a circuit having 3 series connected resistors, having resistance 4 ohms, 9 ohms, and 11 ohms. Determine the current flowing through and the potential difference across 9 ohms resistor. Find also the power dissipated in the 11 ohm resistor. Now, the first thing we need to do, we need to understand that the parameters that have been given to us, we have R1 to be 4 ohms, we have R2 to be 9 ohms, we have R3 to be 11 ohms. So these are informations that we already have. And then we have V equal to 12 volts. So the first thing we're going to do is to use V equals to IR. Now this is from Ohm's law. This is what Ohm's law states. For we to get the voltage we need the current, and then we need the total resistance. For we to get the total resistance, it becomes RT equal to 4 plus 9 plus 11, which will give us a total of 24 ohms. Now that we have the total resistance to be 24, it means we can calculate the current since we have the V that's been given to us. So in that case, I equal to V divided by R total resistance. And we have been given V at V is 12 volts divided by 24, which will give us 0.5 amp. Okay, so this will be 0.5. So once you've done that, then it becomes easy for we to calculate V2. Okay, so in the diagram, it indicated as V1, although on a normal case, it means we're going to have V1, V2, V3 because we have three resistors connected in parallel. It means there will be voltage drop across each of these resistors. It means, so in this case, V1 is across the 9 ohms resistor. Okay, so that's the potential difference across the 9 ohms resistor. So that's the most important thing. So we're going to say I equal to the V1 over the 9 ohms resistor. So it's going to be resistor 9 in that case. So resistor 9. So that's resistor 9. So for we to get V1, it's going to be, it's going to be V1 equal to I, it's going to be constant, then it's going to be arrow 2. Okay? Or let me maintain it to say arrow 9, which is a 9 ohms resistor. Now, if I put it that way, arrow 9 means 9 ohms resistor. So therefore, V1 is going to be equal to I is 0.5. Now, the resistor, the 9 ohms resistor, which is the second resistor, has 9 ohms. So it's going to be multiplied by 9. Okay, so it's also the same thing as resistor 2, the second resistor. From the question, it stated that the 9 ohms resistor, it's also the second resistor. Okay, so the resistor is 9 ohms. When you multiply that, you're going to get 9 multiplied by 0.5. This will give us 4.5. That's half of 9. We're going to get 4.5 volts. Then the last question says, find also the power dissipated in the 11th ohms resistor. So since we are concerned about the 11 ohms resistor, it means we need to carefully check which formula we can use a straightforward formula. So in that case, for we to get the power, so power equals to I multiplied by V. Now from Ohm's law, which says V equals to I R. So it means if we replace V with I arrow in the power equation, we're going to have P equal to I multiplied by I R. So that is going to give us P equal to I square multiplied by R. Now this is going to be the right formula because we are considering the resistor, the 11th ohm resistor. So in that case, we're going to say P equal to into bracket 0.5 square multiplied by 11, which is 11 ohms resistor. In this case, we're going to get P equal to 2.75 watts. This is the answer. So this is pretty straightforward. At this point, I've been able to solve some exercises as related to resistors connected in series. So please pay attention to the subsequent videos in this channel. All right then, enjoy this video. Bye.